Have you ever wondered how deep tech companies actually start? Well, we were too.
So in this podcast, we'll be interviewing scientists and entrepreneurs that have taken their ideas out of the lab and turned them into startups. I'm Antonia.
And I'm Christina, and this is Startup the Science. Hi everyone, thanks for tuning in to another episode of Startup the Science. Before we get started with today's episode, I just wanted to give a shout out to everyone involved in the 2020 ADMACOM program. If this is your first time tuning in, ADMACOM is our yearly accelerator program for advanced materials startups. And in the last 2 weeks, we've been working hard, putting all the startup finalists through so many workshops, trainings, mentoring sessions. It was intense, but at the same time, it was so much fun. And if you're at all curious about the startups or the program, I really highly recommend going to see the demo day. It was live streamed last week, and it's now on our YouTube channel, and I'll leave the link in the description. But on that note, I would also like to really thank our sponsors who, without them, this program would not have happened. So big thanks to IBB, the Investment Bank of Berlin. A big thank you as well to Berlin Partner for Business and Technology. And last but not least, a huge thank you to Sonnenberg Harrison Partnerschaft. Now, this is actually a really great segue to today's guest because they are all too familiar with ADMACOM as they were a startup finalist in last year's program. Today's episode features the founder of ATLANT 3D Nanosystems. They are based in Denmark, and we got to know Maxim, the founder and CEO of ATLANT, at last year's program. But as you might be able to tell from this episode, I don't think we actually knew Maxim at all. There are stories he tells us in this episode that just blew our minds. I think the one thing I really started to notice after a conversation with him is that he has this undeniable entrepreneurial spirit about him. And I think that's something really to be admired. So without further ado, here is our conversation with Maxim from ATLANT 3D Nanosystems.
Hi, Maxim, and welcome to Startup the Science today. It's really great to have you with us today. So we'll be talking about ATLANT 3D Nanosystems, a wonderful startup that we love since ADMACOM last year, and that you'll tell us more about. So welcome, and tell us a little bit about yourself and what your startup does.
Hi, Antonia. Thank you for inviting to talk with you, and it's a great pleasure and honor to be here to give you a presentation and have this discussion with you and to the audience. I'm very glad to tell others about our company, about our startup. We are a deep tech startup in Denmark, also with R&D location in Germany, in Erlangen. And we are the first company in the world that develops atomic layer 3D printing technology for rapid prototyping of micro nanodevices and material development for electronic industry. So the uniqueness of our solution is that we enable printing of electronic materials at atomic scale. We call it printing on demand, atom by atom.
This is very cool. And as our listeners know, I am not, Christina's not a scientist, but what we do is we interview a lot of scientists and a lot of technologists, and we ask them to explain science to us. And even though we don't know a whole lot about 3D printing, I know that ever since we saw your application last year for ADMACOM, the whole idea of printing, 3D printing atom by atom, so atomic layer 3D printing, was very exciting. And lots of people got very interested in that topic and thought, oh, this is very cool. We haven't seen anything like it. And like you say, you're the first ones doing that. So can you tell us a little bit more about this technology? What does it mean? How is it possible? And how come nobody else is doing that?
Sure. I'm very glad to talk about this as well. Yeah, so we actually came up to this concept by bringing some unique experts in one place. not even experts, but more expertise. So I came up from the microtechnology field, and I was working in the clean room facilities, fabricating solar cells, working daily on fabrication of different micro devices. And I saw the challenge that comes from this industry, from this daily routine, when you need to make one simple sensor and you spend a lot of time just on very small iterations of simple processes, but you need to repeat one by one. At the same time, I saw the huge potential of atomic layer deposition technology, which I was not expert in, but I was more as a user. And at one of the conferences, I met with ALD experts, and then we had discussions, and basically we came up to the decision and conclusion that combining some of the microtechnology concept and combining atomic layer deposition concept might bring the unique capabilities. Later on, we also discussed the atomic, or not atomic, 3D printing concept. And this is how all these three fields were combined in one. This is how the whole concept was, let's say, when it appeared to the audience, to everyone. So basically, we are combining highly sophisticated technologies together in order to make atomic layer 3D printers. So for more specialized experts in the field, we're making atomic layer 3D printer. The machine that can, the same capabilities as ALD, atomic layer deposition, print atomic layers, but selectively, whenever one wants, on demand, with a lateral resolution in microscale range.
Okay, and so in simple terms, for our simple understanding, what are we 3D printing in this case?
In this case, we are 3D printing micro nano layers. So we're targeting first to print simple sensors, let's say a temperature sensor or pressure sensor, or printing some contacts for electronics. This is just the beginning. The imagination of human can be different, and how this can be used further, it's even difficult to predict. What we foresee that this technology can be applicable from a very simple micro device of sensor fabrication to much more complex devices like multi-layer, even integrated circuits. But for this, we need some time.
Right. So your technology could be used to develop these micro nano devices, but also to develop new materials, right? And this is one of the reasons why you were such a big part of ENAM now and of ADMOCOM last year, because you are working in the field of new materials, advanced materials, and helping develop these in a different way. Can you tell us a little bit more about that? How can new materials be developed with your technology?
Yeah, it's a really good question. Indeed, our technology in initial phase, the most favorable for material development. The reason for this is the next. Right now, the existing technologies require a whole setup and a whole big sample to just deposit one sample, one material sample. Now imagine when you have a 3D printer and that can go and create dots. Let's say one dot deposited or processed at one temperature, then at second temperature, third, and so on. And you can create a number of new samples just within a few minutes. You don't need to unload the sample from the chamber, even from vacuum chamber, and then load a new one, and then reproduce this many times, spending just 1 or 2 hours for one sample. Here you can get just one sample within minutes. So this reduces the time, that reduces the cost, and actually you can even experiment on a very small samples. This is the unique value that we can bring to any material development scientist or engineer in the industry and academia even now. This is how we can help. And since it's based on atomic layer deposition technology, so this technology is unique by providing more than 450 different materials. This is the huge value that our technology can bring. The selection of materials that can be used for quantum computing, for photonics, for sensors, for MEMS, in different industries. So we just extremely excited how this can be moving further.
So your technology would work across a wide variety of industries, right? So it's hard to say that you are only specialized in one field or one technology, because you actually work across a wider range, which is also why it's hard to ask you, for example, how competitive is this field, right? Because it depends what you focus on first. But where have you seen ATLANT get the most traction so far? Where are your customers coming from? Where are the potential collaborators coming from?
So far, we got the most interest from biomedical field, even biopharma field. That was our first pilot project. Now we get in from light LED field some interest, from packaging, advanced packaging field. What would be the next? It's difficult to say. We now scouting different potential customers and industries, and we're trying to define different use cases. What is the most crucial factor for us is if we take different use cases, we try to have them something in common, that we don't have double development because we are limited to resources. And this we directly tell to our customers, explaining that we cannot go diverse in different projects, that if we develop something in one project, we try that it can be scalable in another applications, and then we can help and work with several customers at the same time.
Sounds similar to the approach we take at Inam as well. We try to see if one thing that we do might work across different levels. So actually that leads me to my next question. Can you explain a bit your business model? How is it that you guys work? Do you sell the printers and then those get delivered to the customer and they can use them as they see fit? Or do you sell a service or a license, or how does it work?
So we started with pilots. Now we call pilot projects more research and development as a service. It's a very nice business model because it's a very simple model to start with, work with a customer. It's service based, and we tailor each project according to the customer needs, according to specifications. Therefore, the budget is different. Our idea that as soon as the customer is happy with our development, we developing the machine at the same time. That would be available within the next 2 years for sales, and then we want that such customer happy with our services, they can buy the machine, and we can support them in-house with their development, providing different expertise, providing different materials for testing, and also improving the processes together with them. That's two major business models that we have. But we also foresee that at some point, depending on the stage of development, we would also implement the licensing model. Right now, it's a little bit difficult to say how this would work and in which fields. So we foresee that the most impact would be licensing on certain applications that would be developed with the customer, and the customer, let's say, take our machine and we license our technology to use for that or another application technology.
Sounds good. And I like the fact that you have a couple of different business models, so you can diversify your revenue streams a bit. Is there one particular project or customer collaboration that you'd like to mention that you're really proud of?
We have a very nice collaboration so far with Merck. They're also part of Admacom and Inam network. And they were the first who believed in our technology and actually tested our technology through the pilot project. I believe, developed pretty good relationships with them, and we keep in the communication, and we hope further on to develop some new interesting projects with them.
That's great. So thank you very much for explaining the technology and how you guys work. We followed as much as we could, but I'm sure other people that are more technical will understand even better what you were talking about. We're getting to one of my favorite parts, which is to hear a little bit more about how the idea came about, how you formed your team, and basically how did you get the courage to start something that sounds quite complicated. Let's talk a little bit about the story of ATLANT. So how did this idea come about? I know that you were already doing research in this field. Did you come across this completely new idea while you were doing that, or was it part of a different project?
No, it was not part of a different project. I was a fresh PhD graduate from Danish Technical University, just joined as a postdoc at the RISO lab, part of Danish Technical University. And I was at the lecture of Professor David Munoz from France, and he was presenting his achievements in the field of spatial ALD. It was a very nice lecture, and I was sitting and thinking that, you get in a device that works like a printing, like inkjet printer, and then can print atomic layers. Actually, from that moment, I was thinking why there is no 3D printer based on this. This idea didn't leave me for some time. I was going around talking with different people, with trying to figure out how this can be possible. And while sitting one evening with my friend drinking some nice German beer, we figure out that it can be done in a certain way. So we made the sketches. My kids came next morning to look at the sketches, and they said that they draw that because it was looking like really childish. But it was a very nice sketch that I made a model, 3D model, and then I talked with my PhD advisor, Ole Hansen. And he said, yeah, it sounds really reasonable. Later on, I took that idea and went to a conference, ALD conference in Barcelona. And I presented this idea in the end of the conference, almost a closed room, to another researchers. And one of the researchers, my current CTO, Ivan Kondrata, came to me and said, yeah, you need to redo everything. It will not work like that.
Did you actually redo everything, or what did you do?
Yeah, we sat with him for 4 hours after the conference. We went again to the pub, drink some nice Spanish wine, and bought some snacks from the local market. And, we're having a nice conversation, and then we came up to the concept that we are currently using. So the next day when we came back home, we almost didn't sleep for a few days. And we just created very fast the concept, the description, the models, and then actually within a week we filed a patent. I was very surprised because within a week we convinced several our current collaborators, professors from DTU, from Germany, from Slovakia, that gentlemen, this is the concept that will change everything. And we didn't believe that they would support us, but they said, yeah, you don't have a prototype, but you should definitely patent it. And we submitted the patent, and we started applying for the funding. But since we just fresh graduate with very few publications, Ivan was still a PhD student, so we didn't get any grants to keep it as a research idea. So the next step was actually that we decided, instead of going for research, let's be a startup. Let's raise money fast and build the prototype fast. And that was our beginning of success so far. So we applied, we convinced the committee that we need some money for the prototype. We registered the company end of November 2018. Within a month, we got the first grant, and then we started building the prototype. And that's how the thing started.
That's the story. Well, that's really cool because it's not often that an idea that starts in a bar seems reasonable the next day as well. So, I think that's pretty cool. and also the day after and the day after. So that's very nice. And also extremely impressive that you filed a patent within a week and you got so many people on board. This already sounds very exciting. And I wanted to ask you what you find most exciting about working in a startup like ATLANT, because it's your first startup, right? You haven't, or have you had other companies before?
Yes and no, I would say like this.
Okay.
If we come back like 15 years ago, I was a bachelor student in Ukraine, and I was pretty proactive. I was the head of student union. We had a student council, and these type of organizations were very entrepreneurial. So together with my friend, we organized a tourist company. We made it pretty successful within 3 months. It became a regional leader, and it's still a regional leader in that city. Then after that, in 2 years, I made another company. So it was a video and photography studio, and I was running that for 4 years while being a PhD student.
Okay, very diverse interests.
And then after PhD, actually between my PhD and postdoc, I came up with an idea after working in the clean room, making nano jewelry.
Nano jewelry. What is nano jewelry?
Yes, it sounds really, really unusual, I know. So what was the concept? We were developing black silicon solar cells. And me and my friend in the office, we took this black silicon and then deposited gold, and it looked really cool. So we designed a pitch deck and then went to the DTU proof of concept committee and then convinced them that, guys, we need funding to implement the samples. We already talked with Pandora jewelry company that they are interested in this. And then they gave us money. We didn't expect that they gave us money. So I hired a pretty famous Danish business lady that has her own jewelry brand. She hired a jewelry designer. She has a production in Thailand, sorry. And then within 2 months, she made a collection. And then we started integrating this nano pieces inside of the jewelry. So we create even a whole collection, and we started to talk more closely with Pandora, but they had at that time series of problems, and then every time when they approach, when we about to settle agreement, that something happened in the company, and that was 3 or 4 times. And unlucky for us, it was like that. And actually, at that moment, the ATLANT project started taking power, and I just switched to.
You dropped the nano jewelry, but this is a different topic and probably should be a different episode. But what is nano jewelry? Is it like really tiny jewelry?
Yeah, it uses diffractive coloring, so it's like holography. You can also make nanostructures with different patterns and with different nanostructures that looks really fascinating.
You can see it with the naked eye?
Yes. It's like holography, jewelry with holographic structures or holographic pictures.
That's cool. So if ATLANT, for whatever reason, doesn't work out in the long run, you can always go back to being a jewelry designer, sort of.
Or tourism, or photography. I mean, you can choose all these. You're an onion, Maxim. So many layers. Wow.
So many layers. This is very interesting. We've known you for more than a year, but this we did not know about you. So there you go.
Because you didn't drink beer with me, I can tell you more stories, but we didn't have time for that.
The secret really is in drinking enough together, and then you find out everything. So actually, this year we had, I should say, ADMACOM online. So not a lot of drinking happened, but this is something we need to learn for future editions. That we need to take people to the pub more and get them to tell us their stories. All right, coming back to ATLANT, where it all began, I wanted to ask you what you hope or you think the future of ATLANT looks like. What would you like to have achieved in the next 6 months, a year? And obviously, we're recording at a weird time in history with the pandemic affecting everyone. But perhaps disregarding that to some extent, what should the future of ATLANT look like?
It's an easy and very difficult question. Easy because we are a team of dreamers, and I could say our key criteria when we choose people, they should be extremely creative. So we actually innovate in every step of the company, from how we do the business, how we work, to how we plan do science and engineering. And difficult because we, considering current situation, it's difficult to predict what will be the next. But definitely we have a plan, and this plan is the next. So the next 6 months, we expect to actually finish our industrial prototype, hire about 8 to 10 people. We already hired just within the last 4 months 4, and now hiring a few more. So you should hear this talk. So keep an eye on us because we are looking for highly talented engineers, and not only who wants to change the future atom by atom. So please reach out to me afterward. And the next year, we actually want to expand collaboration with the customers, getting more projects where we can help you with material development or some micro nano device development. By the end of the next year, we plan to actually do some pre-sales of the equipment, with idea that in 2022 we will have equipment to deliver. The long-term strategy that our technology can be the mainstream technology in semiconductor microfabrication, and therefore we cannot foresee what happened the next, but our best wish is that our technology can become a space technology. And for this, we have some things in our pockets that we don't show yet.
Okay, for that, we'll have to invite you to another episode in about a year or so you can share more. So I'm guessing then, if we were to ask you for requests or wishes from our listeners, you've already mentioned some. You're hiring, so people should keep an eye out for any job openings that you have now and that you'll keep having in the future. Are you also, like most startups, raising money or planning to raise money soon? And do you want to talk a little bit about that?
Yes, we are continuously raising money. We, as a startup, we are money hungry. Luckily for us, we so far raised enough funding to build an initial team and start developing our technology, conducting still R&D and product development for the next 2 years, thankfully to European Commission and the Innovation Fund of Denmark. And we see that in order to bring the high quality product and actually speed up a lot of processes, and we need a stronger team, we need to speed up development, and this is why we're raising a seed round. And we're looking for strategic, high-profile investors from our industry, from semiconductor, microtechnology, advanced materials, that can support us. And currently we in the process to raise seed round with a 3 million request. Depending on the situation, we open for different discussions, but I would say that our case in this situation, this difficult COVID situation, is pretty risk low. Because we already secured the funding for the next 2 years, and it's a matter of speeding up and actually bringing the product to the customers. We already have some committed customers who waiting for our product. They just, I would say, calling to us and asking when it would happen.
Well, that's always good to have customers waiting for you. And I'm happy to hear that you've secured funding for at least the next year or 2 years, actually. So that's great. Usually we kind of end the interview on this note of what are your wishes, requests, desires. But since you're like the perfect example for someone that has moved from academia to starting their own company, I'd like to ask you to tell me, what are the most exciting things? What are the things that make you so happy to now be a startup founder and out of the 100% academic world, so that you can inspire a few more scientists perhaps to start their own companies? And we'll end on that happy note.
That's the most difficult question from today, but I'm happy to answer. My advice, my answer would be the next. Don't be afraid to make a company or a startup. Actually, deep tech field is extremely challenging. It's really cool. There are a lot of support for such companies, I would say even more than for software or for any other, because this is a low competition field and this is high demanding field, particularly in European Union. And if you get right partners on board, this is a high chance of success. Of course, everyone can fail. There is no insurance against failure, but you will get much more value by being in startup and running research and development, product development, building the team, than being in academia. You will do basically the same things that you can do in academia, but you will get much more stronger experience, insights than you can get in academia. Academia is very limited. In startup, you are founder, and you plan what should be done. And you know what the industry expects and even what academia expects. What is the most strongest factor that actually gave us a good standing is collaboration. That's our key to success so far, that from the first day we started to collaborate. From even building the idea, anyone can think, okay, this idea, why didn't you develop this idea alone? Why didn't you do this alone? Because many deep tech ideas you cannot develop alone. You always need collaborator. Everyone understands this. And in academia, there is a very good culture of trusting to each other. Of course, there are exceptions, but if you find a reliable, trustful partner, you can build really cool projects, really cool startups and companies. And I would again just suggest go and experiment. Startup, it's a big PhD experiment that never ends, but in the end you get even much more excitement because you see that your ideas can be recognized, you see that you bring the real value to others, and you can change something in this world.
Wonderful. And on the note of changing the world, the starting companies, we'll leave it there, and I'm sure we'll talk to you again soon. Maybe next time you can share more details about your space projects as well.
I will be glad to. And I would like to thank you, Antonia and Christina, for keeping me here, for giving this opportunity. I will be glad to talk with you next time and give you insight what we're doing next.
Sounds good. Talk to you soon.
Bye.
Ciao, ciao.
Thanks for listening to Startup the Science.
If you like our show and want to know more about what we do, check out our website at inam.berlin.
And don't forget to leave us a review. Until next time.